Okay, so now there is this anonymous note that is being found in the science lab. So the lab tech, right? Every school has got this lab tech. So the lab tech carry out paper chromatography using the ink sample of pen from different student who she thought could be the culprit. Okay, so these are the suspect. So she want to find out who is the one who written the love note to her or something, or a hate note or a death note whatsoever. Okay, so she carried out the experiment. She got the chromatogram. Then she is looking at the chromatogram and she has to decide which student is likely to be the one who has written that piece of note. Okay, so from the note, she extracted the ink. Okay, there are 2 spots found on the chromatogram. So as she looked at pen L, okay, pen L, pen M, pen N, and pen O, L has got only 1 spot, even though it coincides, right? What's the meaning of coincide? Okay, it is actually at the same level or same distance travel as the ink from the note. Okay, but because this is missing, therefore, it cannot be this person or this pen that is being used to write the note. Clear? So I'm describing all this, explaining slowly because I want you all to know lah, in order to identify which is the correct pen that is being used, okay, to write this whatever note that's left inside the science lab, you must make sure whatever that appears in the suspect ink, right? Okay, the chromatogram must have the exact spots as that one from the note. Okay, so the pen ink or the note's pen ink has actually indicated that there are 2 spots in the chromatogram from this particular sample. So because pen L has 1 missing spot, okay, pen L, after carrying out the chromatography, there's 1 missing spot. So this is not the pen we are looking for. We look at M. Yes, there is this spot here that seems to be traveling the same distance as the pen ink from the original note. Yeah, but this is an unknown spot. Okay, so unknown spot, it didn't appear over the side. Therefore, M is not the pen that we are actually looking for. Look at N now. Okay, both these spots are actually exactly the same in terms of the distance travel comparing to the pen ink from note. So therefore, this is our suspect. Why is it that O cannot be the suspect? Take a look here. There is 1 unknown spot here. Okay. I should write down there's 1 missing here for M as well. Easier for you all. Okay, even though the 2 spots that are from the pen ink from the note that are exactly the same distance, okay, but there is 1 unknown spot. So this is the unknown spot. That means what? This is not our suspect. So therefore, our answer can only be D. Caris, you understand this now, Caris? I know you tried this, but you got this wrong. So I need you to understand how this is done. Can or not, Caris? Give me a thumbs up or something like that. Okay, I think it's best if you all can let me see your face, then I know whether you're struggling, etc. Okay, it's easier for me to tell from your face than to always ask whether you're okay. So Joven, you must turn on your video. All right. Yeah, I told your mom I want to help you, right? So you turn on your video, okay? I have to give feedback to your mom. So turn on. Caris as well, turn on the video. I know Heidi's one will have some issue. Oh, you're printing the worksheet. Okay, can. Question 2. Evan, okay, Evan? Quickly, done ready? Good. Right, question 2. I have a mixture here that contains solid A and B. So that they change it to substances A and B, but it's okay because substances A and B, they say solid means they are in solid state. That's all. Okay, so solid state, substances A and B are added to 2 different solvents. One is alcohol and one is actually water. So let me highlight this. So I have alcohol and then I have water. Now, The mixture is then filtered. So for each of the solvent used, mixture was filtered. And for the alcohol mixture here, okay, the alcohol that's used as a solvent, I see that after filtration, A and B are stuck or trapped in the filter paper. So what does it tell me? Okay, I can say that A is insoluble in ethanol. No, I will just say alcohol. I just follow exactly the same words. Okay, and then B is also insoluble in alcohol. Can you see that? Okay, so that's why, because they're insoluble, that's why they are trapped here as what? As the residue. Whatever is trapped inside the filter paper, we call it the residue. Whatever flows out is the filtrate. The filtrate is exactly just the solvent. Why is that so? Because nothing can dissolve in it in this case. Now, when I go to the next part, okay, looking at the substance B, substance A inside water, it seems like only substance B, right? Or B is insoluble. Insoluble in what? I want to be specific. So I must write down in water. Okay, B is insoluble in water. A actually is soluble. It dissolved in water. That's why I have water and substance A coming out as the filtrate. So let me change the ink color. Okay, so this is the filtrate. And the only residue here is just substance B. Okay, so substance B is insoluble. That's why it is trapped in the filter paper. So what cannot be concluded from the results of the experiment? A forms a suspension in alcohol. This is true. So it can be concluded. A forms a solution in water. Yep, because it's soluble in water. This is true as well. Now, solid B forms a suspension in alcohol. This is correct because B is insoluble, right? I already put it in here. So this is correct. Now, B forms a solution in water. This is not true because I can see that it is a residue that's being collected after filtration. Okay, meaning it does not dissolve in water. It should form a suspension in water. It should form a suspension in water. Okay, so far so good. Joven, do you understand this part? Can you make sure? Yeah, must make sure you understand, okay? Now, next, let's go on to question 3. What are the two processes used to purify sewage water to obtain new water? Now, you have studied already the new water. You know the processes that are actually taking place, okay, when you want to get new water from the sewage water. So first one is the microfiltration, followed, or you can call it the ultrafiltration, followed by reverse osmosis. The third one is to use the UV light to further clarify the water, kill whatever remnants of the bacteria or viruses, okay? But two main processes, microfiltration, reverse osmosis. So this is the answer. Okay, memorize only this part here. So I have students who ask me, so what is desalination? Now, desalination usually, okay, it is used to purify seawater. Okay, so with the old technique, Singapore, I think our own smart people, our intellects went to do some form of research, and they realized that, okay, they can carry out a certain method that helps to get the new water. So they set up the new water plant. Okay, next. Let's go on to question 4. Now, a ray of light was shone through mediums with different optical density. So what is the meaning of optical density? Okay, so we are looking at those substances that can allow light to pass through, and how do light actually pass through them? Okay, so will light actually change in its speed when it enters this particular medium? So remember, the word medium is important. So what is the meaning of medium? It's just that particular substance light is passing through. Example, air is a medium. Okay, water is another medium. You can also have glass. You can have diamond, you can have many other materials. Okay, so if you're going to compare which medium will have the highest optical density. Now take note, the higher the optical density, right? The higher the optical density, the slower light will be traveling. So highest optical density, light travels through it slowest. So it will be having the lowest speed. So when light travels at a lower speed, when it enters from a less dense medium to a more dense medium, okay, it is going to cause the light to slow down. And when the light slows down in its speed, it's going to bend towards the normal. Clear? So do you all remember this part? Okay, if you can remember this part, then it will be a lot easier. We did a lot of drawing the last time when we were doing that topic right now. Correct? Evan, you can remember. So if you are going to find out which medium will have the highest optical density, you see, this medium, from this medium is usually just traveling at a certain speed. Okay, so this would have been its original path, right now. So when light entered this medium, it seemed to bend towards the normal. Yes or no? Okay, so this is denser than A. Okay, B is denser than A. When the light actually hits this boundary, can you see the speed of light picked up because it is bending away from the normal? So medium C, right, is less dense than B. Can see that or not? Okay, so afterwards, you see that, okay, now the light continues to travel through the medium, hits the boundary, and is going to enter medium D. It is again bending more away from the normal. Can see that? The normal is the perpendicular line. So again, I can say this medium D is less dense than C. So which is the one that is the most dense? The most dense will be B. Can you all see that? So I think Carries and Joven not very strong in this topic, like, yes or not? So how do you determine? You all must be panicking now. I can feel your heartbeat. I can hear it thumping away. Carries, you look very unsure. Yeah, so this is the normal. Okay, you look at this angle. This angle, if you use protractor, is big, right? So this is the angle of incidence. This is the angle of refraction. See how tiny the angle is? So when the angle is very small, that means this light is going nearer to the normal. Okay, so when it goes near to the normal, it tells us what? Okay, light is traveling slowly, slower than before. It's traveling quite slow now. That's why it will bend towards the normal. And that tells me that B must be more dense than A. That's why the change is there. Okay, later I send you a video. So Joven and Carries, you can go and watch that video. Okay, and then using that video, it will be very helpful for you to understand why is it that light slows down, etc. Okay, you have to watch that. Then after that, when it enters this third medium, you see that suddenly this angle becomes so big. What does it tell us? That means this medium must be less dense compared to B. That's why light picks up its speed. It bends away from the normal. Okay, and then here, bend even more. Can you see the size of the angle actually become bigger and bigger? Okay, so the bigger the angle, that means what? The lesser the density. Let's go on now. Question 5. This diagram shows a ray of light striking a plane mirror and getting reflected. Now, when you are looking at this plane mirror, this table here, imagine this is just a table, then you have a plane mirror placed at an angle. This table doesn't affect, okay, the normal. Yeah, you just refer to your plane mirror here, and then this is actually the normal that you should draw. Okay, always draw your normal. Now, and when you want to look for angle of incidence, the angle of incidence or the angle of reflection, right? It doesn't matter so long as It is the angle that is between the light